Welcome.
Thank you. Thank you very much. It sounds like the microphone's working. Everybody in the back can hear? Great. Awesome. I just want to say thank you to Christian for inviting me and to New Relic for putting on this talk. So this is my first time to Portland, so I'm very excited to be here to speak to you today. As you heard, my name is Blithe. You can find me on Twitter and GitHub at Blithe. I work for a company called Fastly. Fastly is a real-time content delivery network that helps businesses scale their websites, mobile apps, and APIs. And they afford me the opportunity to come and give talks like this one. And of course, we're hiring. So I'll be happy to answer any questions about Fastly after the talk. So in a past life, I used to be a scientist. I have a PhD in physical chemistry. And a lot of people are like, what is physical chemistry? So on the spectrum of sciences, it's right on the border between physics and chemistry. So when you have a PhD in physical chemistry, that means you spent a long time in grad school. So I spent 6 years in grad school. What that means is I've done a lot of experiments. And a lot of people ask, how did you do something that was so hard and took so long? Like, how did you make it through that? And I did it using the scientific method. So as a grad student, I methodically tested system after system until we had enough new knowledge to publish a paper. And now I'm a full-time Ruby developer at Fastly, but I'm still using the scientific method every day. So how many of you have encountered an error and gone straight to Stack Overflow? You Google it, you go to Stack Overflow, and you take the first answer on Stack Overflow and you put it in there and you say, does it work?
Programming.
Yes. I think pretty much everyone has done that. And did it solve your problem? Maybe it did. Sometimes it actually works. That method actually works. And maybe even half of the time it works. But that's a pretty inefficient way to write code, for sure. The real question is, when you were using that method of troubleshooting, did you learn anything? Probably not that much. You probably learned maybe how to solve that one little problem, but you weren't really learning in general. And you probably didn't grow that much as a developer by just using Stack Overflow, for sure. And really, if you were in a hiring position, would you hire somebody who only knew how to use Stack Overflow to write code? Probably not. Probably not. The most important part of troubleshooting is not just solving the problem. The most important part is learning. If you solve a problem without learning, it's really just a temporary fix, and it'll probably come back in the future. And you become a better developer by learning from your experiences and building up that knowledge. That brings me back to the scientific method. So how can using the scientific method help you learn and help you level up as a developer? Well, let's talk about what even is the scientific method. Well, if you go Google it and you go to Wikipedia, you'll see this definition. It's a set of techniques for acquiring knowledge. And I actually really love this definition because it can apply to anything, any career, including being a developer. It's not just about science. The scientific method gives you a method for gaining knowledge. It's an established procedure. It's methodical. And scientists have been using it since the 17th century. It's also systematic. So it's a step-by-step process for gaining knowledge and incorporating that knowledge into your process. And the best part about the scientific method is that a time for reflection of what you're doing, the experiments that you're going through, is built into the process. So let me tell you about a story about a former coworker. They were just doing their day job, like coding away, and they popped up into the company chat room and they said, "Has anyone seen Ruby string interpolation fail?" And that was a pretty interesting question. I was like, "What? How can that be failing? Like, how is that not working? Like, what's going on?" So I went over and tried to help. So they were trying to use Factory Girl, which is a Ruby library to help create records in the database. So you can create sequential or unique records. And so they were trying to create, say, like 10 users in the database with unique email addresses using this method. And to do that, they couldn't, there's a built-in method into the library, and it wasn't working, and they couldn't figure it out. So they ended up just writing their own method to do that functionality. And so they wrote their own method and sort of moved on and, submitted a PR. And that really wasn't the best way to solve that problem. And so we finally came to the problem, and we figured it out. What was the real problem? They were missing the pound symbol. They were missing. So if you've ever used Factory Girl, that's a simple typo, basically. You're missing one little thing, and so the functionality doesn't work. And in this case, they came to maybe not the best conclusion, and maybe using the scientific method would have helped in this case. So let's talk about the steps of the scientific method and apply those. So as a scientist, the first thing you do in the scientific method is defining what is the information that you're trying to learn. What's the new thing that you're trying to get? What new piece of information? And as a developer, you can do the same thing. What is the problem that you're trying to solve? Like, let's define that thing. What's really important at this step of the scientific method is forgetting what you think you know is happening already. Maybe you're in a hurry, something goes wrong, and you're typing away, and you're like, oh, I know what the problem is. Let me just do this. Let me fix it. Da, da, da. You're under time pressure. You're stressed. You need to take a step back, take a minute, and actually define what is the problem, what's going wrong. So the best questions to ask are, what are you expecting to happen? What's actually happening? And when you solve this problem, how will you know that you've solved it? What is your criteria for success? And these three questions will help you define the problem of the experiment that you're working on. And this is also really important when you're helping beginners troubleshoot. A lot of times beginners will get down in a deep hole, and they'll have sort of their assumptions about what's going wrong. And they'll come to you and say, oh, this thing is broken, da da da. And often that's not the case. So you need to ignore when you're going to help another person, ignore their assumptions and their pre-conclusions, start from scratch, and just straight out define the problem. Once you know the problem that you're trying to solve, you can start doing research about how to solve it. And honestly, doing your research is sort of something that's always ongoing. You're always learning new things and building up your background information. So in grad school, we were pretty much just constantly reading. When we weren't doing experiments, we'd be reading papers, new journal articles, anything that related to our research, textbooks, anything. Always reading, because you're always gathering background information about, what's happening now, what information can help you in doing your experiment. And the reason it's important to gather all this background information is because you want to be educated enough to do the right experiment first. So you don't want to waste time doing an experiment that's not actually going to help you get to solving your problem faster. You want to know, okay, this is actually the best experiment to try first, and this will give me the most information. So as a developer, you can do that by being familiar with your environment. What's the language that you're using? How can you learn more about it? Go dig around in the internals of the language that you're looking at. For me, that's Ruby most of the time. For when you're working on an application, you can look, as soon as I start a new project, I look at all of the dependencies of the application. How do those work? Which versions are we using, and how are the versions different from one another? You can go read the docs of like, how does this thing work? How do these gems work, or these libraries or anything like that? For the case of the Factory Girl problem, maybe reading the documentation, just taking a look back at the documentation of how to use that would have been like, oh, light bulb, I'm missing that pound symbol. So it's really good to be familiar with your environment. That background helps you know. You can also read blog posts. People are always writing blog posts about current new libraries that are coming out or new versions that are coming out. Same thing with change logs, all those sorts of things. If you want to know specifically about gems that you're using, you can do a bundle open and the gem name, and you can look at the code that's directly in the gem that you're using, so you can see how stuff's working in there. You can also look at the test suites of those dependencies that you're using, because that'll give you some expected information about the expected behavior of those libraries. So that's all helpful, super helpful information. Another super helpful thing for background information is having discussions with other people, or of course, the rubber duck. I can't tell you how many times I have solved a problem just by talking about it out loud to something like a rubber duck or anything like that, a little dinosaur on your desk, whatever. Sometimes it really helps. Or talking to your colleagues or your friends. Maybe they've already encountered the problem that you're encountering, and they know the best experiment for you to try first. Like, oh, this, I encountered this once, you should try this first. So that's super helpful background information. Another thing I like to point out about this, when you're troubleshooting something and you're stuck on a problem, you really want to limit that time that you're spending on that by yourself to a little, like probably less than an hour. If you don't solve something in an hour on your own, that's a good time to reach out to somebody else. And maybe they have extra information that will help you. Another good source of information about the problem that you're having is, can you make that problem happen again? Can you make it fail again? Can you reproduce the error? And if you can, what are the steps that it takes? That's super valuable information. And that can also help you to write an automated test to recreate that error again and again and again. So all of that information helps you figure out what is the best experiment that you should try. So now that you've got all that background info, you can establish a hypothesis. And in science, a hypothesis is, it's educated and it's based on evidence. So this all goes back to the research that you've been doing about your environment and the current state of your application. A hypothesis also needs to be something that you can test. So this goes back to defining the problem. How will you know when you solved your problem? Your hypothesis has to be something that has a definite outcome. Once you have your hypothesis, you can start to design your experiment. And what you need to focus on this is, does it test the hypothesis that you've decided? Don't do a wrong experiment that doesn't even test what you're thinking is the problem. Some tips for designing the experiment for troubleshooting. My favorite tip is to divide and conquer. So if you have this code base, this massive code base that you're working in, which it happens. I'm just imagining all the massive code bases that I've worked in that there's corners in there that I don't even know. You don't go there. You don't go in those dark corners. So what you want to do is you want to be able to focus on just the code that you're trying to troubleshoot. So one way to do this is to write an automated test. So since you know how to make it fail, you can just run that one test over and over and over again, and it's just hitting the code that you're interested in. You can also, for instance, if you know that there are parts of the code that are not affecting the part that you're running, you can just comment them out. Say, all right, if I comment out this code, is it still failing? Yes. Okay. So get rid of that code. The problem code is in this section. You can also use breakpoints. There's many options for Ruby. I'm usually using a binding.pry. So you can stick it right in there, or even multiple breakpoints. So you can see, okay, the code is working in sequence all the way up until this point, and then after this point is when it breaks. So that allows you to sort of be in the environment where the code is going wrong, I should say. Another thing that might help is, can you, if maybe the problem is not in your code base. Maybe it's in a dependency or something. Can you replicate that in a fresh environment that doesn't have anything to do with your code? Why not? Try it out. See if it's still broken in a brand new environment. So those are all ways to divide and conquer a problem. Another important thing for the scientific method is to limit the variables that you're testing, one at a time. So when you watch beginning developers troubleshoot, they often change a lot of things at once. Well, I tried this in the controller, and then I changed this in the model, and I put this over here, and sometimes it gets so messed up, they get down a road that it's really hard to come back from. They can't even say what they changed anymore, and that makes it really hard to troubleshoot. So you really just want to test one hypothesis at a time, and you want to finish your experiment before starting the next one. So that's really important. Don't change multiple variables at one time. Another good piece of advice is to try something weird. You know, sometimes you run out of options. You're like, I don't know, it's late. I want to go to bed. I don't know. Go ahead and try something that maybe you don't even think it's going to work. Just try it. Just see, you know, if it doesn't take a long time to try it, go ahead and try it. For one example, you know, what if like you think you're running a piece of code and you just type in a bunch of gibberish in there and you're like, well, I know this is going to break it, right? It's just gibberish. What happens when it doesn't break? Obviously that code is not running. There's something else wrong. So go ahead and make it, you know, try something that you know is going to break it. And if it doesn't break, that's helpful information. Another good example of this, a friend of mine, you know, they were creating a new application. They made a new table, and they were trying to keep working, and they were trying to like combine some things together, and they were trying to do table joins, and they were getting some obscure error, and they couldn't figure out what was going on. And they're like, whatever, I'm gonna delete it. I'm gonna create it over again. I'm gonna name the table bananas, whatever. So they did it. Bananas worked. Why would bananas fix it? So it turned out that they had named the initial table attributes, which for those of you that don't know, that's a reserved, protected word. So using attributes as a table name would obviously cause an error in Ruby. So naming the table bananas solved the problem. But if they would have just gone on, they wouldn't have understood what the problem was. I think they named it something else, but that would be good. But the point of all this is don't be afraid to try something weird or something that you know is gonna break the problem. That's also helpful information. So how many of you have done something like this, where you do this huge deep dive, like deep down into the dark places in the code? You don't know what's going on, you're stuck. And it turns out to be something right at the surface, something right in front of you. Yeah, oh yeah, me too. So when you're designing your scientific experiment, you want to focus on the hierarchy of blame. So what that means is you want to focus on eliminating the things that are most likely to be the problem first. And then once you've eliminated those variables as the problem, then go on to something deeper, like binary code or so you want to focus on the most likely place that the problem was caused. So was there code that was changed recently? That might be the culprit. That's something that was changed recently, or something that you changed or you wrote. I always blame myself first. Like probably it's my code. That let me just check out the code that I wrote and let me see if that was a problem or not. Things that you wrote are far more likely to be the problem than, say, Ruby. So in the case of the string interpolation not working, that would probably be lower on the hierarchy of blame of likely problems. So yeah, so think about all these things when you're designing your experiment. Once you have a plan, then you can go ahead and gather the data. carry it out, and you want to get all of the information that's going to help you do your analysis. So you've done your experiment. You want to know what's the current state of your environment. Those changes that you made, do you have any new results, new error messages, anything like that? What do the logs files say? Is there any helpful information in there? What if you're using any kind of metrics? What do the metrics say? Were there any changes? Does it look like there's anything wrong there? When you're gathering your data, this shouldn't need to be said, but I even need to tell myself sometimes. Read the error message. Just read it. Sometimes there's a nice, helpful line number there to tell you where in the code it's going wrong. That's super helpful information, and sometimes we just skip over it because we think we know what the problem is. The stack trace is also helpful information, like how did you even get to that point in the code? It's all part of the data to help you figure out what's going on and what has changed. So once you gather all that data, you need to analyze your results. And this is the really important part, because this is where the learning happens. Don't skip the analysis. Don't just go on to the next experiment. So take some time to think about it. The problem, did you meet the criteria for success that you were saying, that you defined initially? That test that you wrote, the automated test, is that passing now? If so, that's good. But are all of the tests passing? Because you need that too. You need your whole test suite to be passing. You also need to think about, what did you learn from that change? Why did changing the table name to bananas, why did that work? Why? So take the time after you've gathered the data and you're figuring out what's happening. Take the time to reflect. What went well with that experiment and what didn't go well? Have you ever said, I don't know why we fixed it. I don't know how we fixed it, but it works now. I have said that. Well, I have news for you. If you don't know how you fixed it, then it's not fixed. It's temporarily gone away. So it's really important to understand why you fixed it. That's the part that cements the knowledge in your brain. And this is also particularly important for people who are in leadership or mentoring positions. If you're helping someone, it's really important for them to explain to you why things weren't working, like what's happening, because that's what's going to help them learn, and that's really important. As part of your analysis, you can also start to think about your future experiments. So the results that you got, what is the next experiment that you should do? Either immediately, if you didn't solve your problem, like what is the exact next thing you should do? Or in the future, it's going to help you design your experiments when you encounter problems like that in the future. And a really important part of this analysis process is embracing your success. And this is also particularly important for beginners. If you solve the problem and your tests are passing and everything's great, take a minute to let that sink in. Like, you did it, you solved it, you figured it out, you learned something, and now you just by one tiny little step, you're now a more experienced developer. You're a little bit smarter, and that's awesome. So embrace that. And even if you didn't solve the problem, maybe you're getting a new error message. That is progress. You've made progress, and you should be encouraged by the new error message. So now you have new data, you can try a new experiment. So that's really important. Another important part of the scientific method is keeping a good lab notebook. The reason you should do this is because it helps tell the story of your experiences, both to other developers and to yourself in the future. What happened? What was the story of the thing that happened? So this is one of my lab notebooks from grad school. I probably filled up 10 of these books. It's just constantly writing. We're always writing stuff. And why were we doing that in grad school as a scientist? Because you are not going to remember everything that you've done. There's no way you're going to remember. So when I was in grad school, we probably did maybe 20 to 30 experiments a day, changing one tiny variable at a time and seeing like what happened. And it's just not possible to remember all those details. 6 years of grad school times 30 experiments a day, like you can't remember all those details. So that's why you write it down. You might think that you have enough information in your logs or something else, your GitHub commits, that'll be enough. That information is not enough. It's up to you to gather the meaning, to glean the meaning from the logs. Sometimes too much information can be just as bad as too little information. So it's really important for you to gather the information, the pertinent information from your experiments. So the first step you can do to keeping a good lab notebook is leaving a good commit message when you commit the changes for after you've solved your problem. Other people are going to read this later. Why did you make that change? What was happening? What needed to be changed? Other people are going to read this later, and maybe even you will read this later. When you do the get blame and it's yourself, and it says, oh, that's why I made that change. I remember. Another helpful thing, that test that you wrote for this failing scenario, that is also now going to be part of the lab notebook. It's going to say right there in the commit message, like, what is the expected behavior? What did you have to do to get it to do that? Another helpful way of keeping a good lab notebook is updating the documentation. Now that you have that information fresh in your brain, go ahead and update the documentation. So maybe the README was wrong or out of date or something. Or maybe you were getting an error because you were missing an environment variable that wasn't documented. Go ahead and go and document those things for the next person. If the error is outside of your code base, maybe it's in a library that you're using, go ahead and contribute back to open source. Go and help out. Open an issue. That's a first minimal step. If you know how to reproduce the bug with a test, maybe you can write a test and just submit a PR with just the test, even if you don't know how to fix it. That's helpful. If you do know how to fix it, awesome. Go ahead, submit a PR. People will love you. They'll love you. They'll say, yes, thank you. Another good thing you can do is blog about your experiences. Have you ever Googled for some problem that you're having? You Google it, and then the first result is a blog post that you wrote. You're like, yes, thanks, old me. This is very handy. I'll use this again. So everyone can write a blog. Everyone can, and hopefully all of you will start doing this today. You can also write your failed experiments. Maybe you never solved the problem or you don't understand what's going on. You can write a blog post and let other people know. Maybe somebody else knows how to solve the problem. But either way, it's a nice record of things that you've experienced. It's really important that you're sharing the information and your experience. Academia and science is all about gaining knowledge about the world, about science, and then sharing it with others through publications. And I think developers can really learn from this. So when you're encountering problems or learning things, go ahead and tweet about them or blog about them, or go and talk at conferences about something you learned how to build or do. But yeah, go ahead and give back. Blog about it, share it, everything. That's the biggest, most important thing, I think. So that's everything I have. Thanks.